Hey guys, so a student sent me a email asking about this particular topic. She was asking if we could go over this, so I said sure, why not? I can share this with the entire class. So the topic is using the conjugate zeros theorem to find all zeros of a polynomial. And they've given us a p of x. So give me a second here and let me get a clean sheet of paper. This looks clean to you guys, but I do have some notes at the bottom here. So they've given me a p of x, and you can see that there in the problem that I've provided. And they're saying that given that negative 2 minus I is a 0, find the other zeros. Well, maybe there's one thing that we need for this. So let's write a note. There's one note that I would maybe put down is that when we are discussing complex roots or complex zeros, we need to remember that complex roots come in pairs. And let me be specific. Complex roots that are written in the form of a plus bi, for example, where you have a real part and an imaginary part that you can see up there. So in this case, my a is my negative 2, and of course my b would be negative 1 in the case of the complex root that's provided. So I know that I have a root of negative 2 minus I. If they give me this, then what I know is that I have another root. So if a plus bi is a root, then the other root is going to be a minus bi. It's your conjugate. We got to remember that word conjugate. So in the case of this root, if negative 2 minus I is a root, then I also know that negative 2 plus I is also a root. So I'm going to slide this over. And that helps me. There's a few different ways we can work this out to find the other root. And let me back up a minute. Some of you might be saying, well, Miss Latoya, how do I know I have another root? Let me write this out for a minute. As a reminder of how we know, how many roots should I be looking for? So the degree of this polynomial is found by looking at that highest exponent, that 3 in this case. And that 3 tells me that I have 3 roots. When I take my imaginary or my complex roots and I add those to the number of real roots that I have, in total I'm going to have a total number of 3 roots, or in this case zeros. I should use the correct term. 3 zeros. Well, I have 2. I need to find one more. I'm missing one. So the question is, how do I find that? Well, what I would do is, there's a few different ways, but what I would maybe do, since I have 2 roots, what I could do here is take these roots and write them in what we call factored form. And y'all bear with me. And I'm going to multiply this, and because when I multiply this, I will have a polynomial, and that polynomial will end up being a factor of this. And what I can do is divide this polynomial by the product of these two, and that should give me my remaining root. What I'm doing is I'm just multiplying these two factors together, okay? I have a trick here, a way that I like to multiply these, so y'all bear with me. What I'm going to do is I'm going to distribute that negative through here, and I'm going to just distribute the negative with that negative 2, that minus there with that negative 2, and I'm just going to leave the I. In other words, I'm going to shift these parentheses. Just watch me for a second. I'm going to bring this down, and this I'm going to group the x plus 2, and then this negative times that negative there, that's going to give me plus I, okay? And I'm going to do the same thing here. I'm going to put x plus 2. And then that negative times that positive gives me a minus I. So why did I do that? This is kind of in the form of conjugates, right? My real part is the same. And then my imaginary part, they are opposites, have one plus and one minus. That helps me when I go to multiply this. Because if you remember, when you multiply conjugates, all you have to do is multiply the first two terms together. So in this case, it's x plus 2 squared. Then multiply those last two terms together, and it gives me minus I squared. And if you remember, another note, let's change my color here. So I can say note that if I square anything, a binomial in the form of a plus b squared, remember that pattern is a squared plus 2ab plus b squared. Well, that helps me out because if you remember that pattern, you can square this fairly simple, quickly. So that would give me x squared plus 2 times ab, so my a and my b would give me 2x, multiply that times 2, that gives me 4x, and then square that last term, that gives me 4. Alright, and then minus, remember your I squared equals -1, so minus a -1, which is really just plus 1, so that really gives me x squared plus 4x plus 5. So this, guys, is a factor of all of this. What I did is I multiplied those two roots together, right? Those two, I multiplied these factors to get a new polynomial. This is just this written in a different form, right? I don't have the imaginary parts. But what I'm going to do is I'm going to take and divide this polynomial. I'm going to take this x cubed plus x squared minus 7x minus 15, and I'm going to divide it by this factor that I found, this x squared plus 4x plus 5. Okay, and the result here, if I do this correctly, the remainder should be 0, right? And what that tells me, if the remainder is 0, then what I will have will be my remaining factor. So let's try this. Remember, we're going to look at these first terms, right? We're going to take that x cubed and divide it by x squared, and that will, in this case, give us x. X times x squared gives me x cubed. X times 4x gives me a positive 4x squared, and x times 5 gives me a positive 5x. And if you remember in class, I kind of like to put my minus there in parentheses to remind me that I'm subtracting everything. So x cubed minus x cubed, they cancel one another out. X squared minus a positive 4x, so that's really 1x squared minus 4x squared, that gives me a negative 3x squared. I have a negative 7 minus a positive 5, so that's negative 7 minus 5, which gives me a negative 2x. And then remember to drop down that last term. Okay, once we get here, we're going to remember to look at that first term. We're going to take that first term, not just the 3, the whole thing there, the whole term. We're going to take that negative 3x squared and divide it by x squared, and that would give me minus 3. Okay, so a negative 3 times x squared gives me a negative 3x squared. A negative 3 times 4x will give me 12x. Ooh, I messed up. And I see what I did. So we'll fix that. And then negative 3 times 5 gives me a negative 15. And then if I subtract this, it is supposed to give me 0. And I added wrong. I don't know if I said this wrong. I think I said this wrong. But this was negative 7 minus 5. It doesn't give me negative 2. You add those because essentially those are both negatives. So that should have been a 12. So go back and add that. I made a mistake, and I'm not going to redo this video just for one little mistake. So we're going to leave that, which is okay. The numbers still are there, and it's still pretty. And what we see is that everything is the same. So if I subtract those, I do get 0. So what that tells me is that x minus 3 is a factor. So my factors here, let's put this in factored form, are x minus a negative 2 minus I. Then I have x minus a negative 2 plus I. And then I have x minus 3. And remember, I could put a bracket just so it all looks the same. Ooh, there. I'm sorry about that. I was off the screen. Remember that when you have your roots or your zeros, that if you have, so a note, again, when you have your factors in this form, right, that C is your root or your 0. Okay, that is your root or your 0, however you want to look at it. So that means the minus sign, we don't really take the minus into account. Is the C is the root or the 0. So in this case, that lets me know that negative 2 minus I is a root or a 0. That negative 2 plus I is a 0, which we knew that from the very beginning, way up here. But then my last one that we have was, oh, I shouldn't have highlighted the minus, but it's 3. So my last root was 3. And I wonder if it will show me the solution here. Negative 2 plus I, which is what we have, and a positive 3. So there you go. If you guys have any questions, let's see if I can zoom up a little bit where you guys can get one more look at this. If you guys have any questions, do not hesitate to reach out. I am more than happy to help.